Okay, so welcome to this third tutorial. And in fact, in this third tutorial, we are going to practice the thing which we have studied yesterday only. Right. So yesterday we were discussing about the electric field intensity due to infinite line charge. Right. So for that, let me take you through the things which we have done yesterday. Are you able to see that? Hello.
Yes, sir.
Okay. So yesterday we actually focused on finding electric field intensity due to infinite line charge. See, we have the Coulomb's law. After that, we studied electric field intensity and electric field intensity due to point charge. This thing we are now familiar with. Means if the point charge is given, the way in which we can calculate the electric field intensity is very easy. By using direct formula, you can do that, right? So a formula for that is written over here. What is that formula? Electric field intensity E bar is equal to Q upon 4 pi epsilon naught R square A bar R. This is equation number 1, right? So we know that if point charge is given by using this formula, that is formula number 1, you can easily calculate the electric field intensity. But the problem arises when the charge configuration is different other than point charge. It can be line charge, it can be surface charge, or it can be a volume charge, right? So we have taken first case, that is infinite line charge. We have assumed the charge is considered to be a line charge, right? So you can consider this line charge as a straight line, or you can consider it anywhere having number of point charges uniformly distributed over the entire length of that line. That means you are having a series of point charges that can be treated as a line charge. Now for this case, just to simplify the equations, we have assumed. The assumptions are like uniform, this infinite line charge is placed on z axis, right? So half of that towards positive z, half of that towards negative z axis, right? Having center at origin. So this way we have placed the infinite line charge. Then we have assumed then we have created a small point charge called as dq. This is our step 1, right? So we have created dq here having coordinate 0, 0, z. And because of that dq, how much electric field intensity is produced at point P? This P is assumed at 0, y, 0. And in terms of cylindrical coordinate system, it's r, 0, 0. Right. So we know the end coordinates. So we have calculated the vector. Right. So the vector is r bar is equal to r a bar r minus z a bar z. And from that we have also calculated the unit vector. Unit vector is vector upon magnitude. So this way we have calculated the unit vector as well. The next step is to find differential electric field intensity dE bar. So dE bar can be found from equation 1 itself, right? So this is complete electric field. I want differential electric field. So for differential electric field, I can write dE bar is equal to dQ upon 4 pi epsilon naught r square a bar r. So this is just we can write from equation 1. And finally, in place of dq, what I can write? Rho L dz. In place of dq, what I can write is rho L dz. And a bar r written over here. Right? So this is the equation that we have seen yesterday. After that, we have simplified this, like if I multiply this r square plus z square by under root r square plus z square, it becomes r square plus z square bracket raised to 3 by 2. And I told you this vertical component gets cancelled because of a similar point on negative side. If I consider dq here, there exists a dq at the negative side also. and vertical component of dq on a positive side will be cancelled with vertical component of dq on negative side. Only radial components gets added. So when we take the integration, you can cancel this vertical component, that is z a bar z, right? So this z a bar z gets cancelled, and remaining terms I have written here in this equation. So what equation we are getting? E bar is equal to integration dE bar. It is equal to integration minus infinity to plus infinity, because we don't know the length. We have assumed it's a infinite, right? That's why minus infinity to plus infinity, rho L R dz into a bar r divided by 4 pi epsilon naught into bracket r square plus z square bracket raised to 3 by 2. So to this point we have reached yesterday, right? So shall we proceed from this point onwards? Shall we proceed from this point onwards?
Yes, sir.
Okay. So I hope the screen is visible. Now, let me just write the equation once again here to begin with. What was that equation? E bar is equal to E bar is equal to integration minus infinity to plus infinity, right? Here we have rho L R dz. Rho L is your line charge density. Rho L, line charge density. R is the radius. dz divided by, of course, the direction component is a bar r, divided by 4 pi epsilon naught into bracket r square plus z square bracket raised to 3 by 2, right? So up to this point we have seen yesterday, right? Now I want to change the limits. I want to change the limits of this integration. So I have to do some substitution. What substitution can be possible here? What substitution is possible? If you look, just a minute. Yes, so I want your concentration on this triangle. What is this triangle? Let me take this as a Q. Then I want to focus on this triangle, right? So from DQ to origin, origin to P, this triangle I'm going to draw once again. Which is actually a right angle triangle. So if I draw it here, so this is your Z, this is your radius, that is the distance from origin to the point P, and this way I can complete the triangle. Yeah. So if you look at this triangle, this is right angle triangle, right? This is right angle triangle. This is the point where you are having DQ, right? This is the point you are finding your electric field intensity. So point P, and this is your origin, right? So if I talk about this side, the length we have assumed it is Z. Make me correct if I'm wrong. This is Z. This is what we call as a Z, right? So this is at distance Z, and this distance is R. This distance is r. So once again, I'll take you to the same diagram. Yes, if you can see this, we have taken this coordinate at 0, 0, z by assuming its distance from origin is z, right? Here also, we have taken its value, its distance from this z axis, or you can say origin is r, or you can say y, right? And we have said r is equal to y in that case, right? So its distance is y, or you can say r, right? So I hope now you understood from where this triangle is taken here. Now for this case, for this particular case, what I can write for right angle triangle? For right angle triangle. For right angle triangle. If you can remember some mathematics, I will write here tan theta. Let us assume this is just a minute. Let us say this is angle T. Angle T. Right? Now, in case of any right angle triangle, we know that tan theta is equal to opposite side upon adjacent side. Am I correct?
Yes, sir.
Yes. So for right angle triangle, if I write tan theta, it would be opposite side upon adjacent side. And for this triangle, what I can write is?
Tan T is equal to Z by R.
Correct. Tan T is equal to Z by R. So from that, I can write Z is equal to R tan T. R tan T. So this is your substitution. This is your substitution. So put Z is equal to R tan T. So if I do that, what will happen? What will happen with the limits? Limits. Z ची value, if it tends to infinity, minus infinity. या इक्वेशन मध्ये z ची व्हॅल्यू मायनस इन्फिनिटी असेल तर t ची व्हॅल्यू काय असेल? You have the calculator. You put z is equal to infinity, you will find t is equal to minus pi by 2. t ची व्हॅल्यू त्या वरच्या इक्वेशन मध्ये मायनस पाय बाय 2 ठेवा. बघा z ची व्हॅल्यू जी आहे ती मायनस इन्फिनिटी येईल. Similarly, if z tends to infinity, in that case t becomes pi by 2. T tends to pi by 2. So we get new limits for the integration. We get new limits for the integration. Now further, I want a substitution for this part. Just a minute. I want a substitution for this part, right? म्हणजेच काय, ब्रॅकेट मध्ये r square plus z square raised to 3/2. For this term, I want the substitution. So for that, what I can do is, let us differentiate this with respect to t. So what I'll get is dz is equal to, मी काय केलं याला डिफरन्शिएट केलं विथ रिस्पेक्ट टू टी, r sec square t dt, r sec square t dt. म्हणजे आता मला ह्या टर्म साठी सबस्टिट्यूशन मिळाली, म्हणजेच काय dz साठी सबस्टिट्यूशन मिळाली, राईट. dz आणि हा जो खालचा सर्कल आहे ह्याच्यासाठी आपल्याला सबस्टिट्यूशन कॅल्क्युलेट करायचे. सो फॉर दॅट the term, if I take here r square plus z square bracket raised to 3/2 bracket raised to 3/2, so this is equal to इथं काय लिहिता येईल, r square as it is, r square plus म्हणजे पूर्ण इक्वेशन मी फक्त इन टर्म्स ऑफ r लिहायचं म्हटलं तर r square. z साठी काय सबस्टिट्यूशन आहे, दिस इज युअर सबस्टिट्यूशन, दिस इज द सबस्टिट्यूशन, राईट. सो z च्या ऐवजी काय लिहिणार मी आता, इन प्लेस ऑफ z वी कॅन राईट
r square tan square t.
r square tan square t. r square tan square t bracket raised to 3/2 bracket raised to 3/2. Is it clear up to this point? बघा मी काय काय सबस्टिट्यूट करणार आहे, काय काय व्हॅल्यूज आता चेंज करणार आहे. मला लिमिट्स, नवीन लिमिट्स मिळालेले आहेत, dz ची नवीन व्हॅल्यू भेटलेली आहे आणि आता मी ते डिनॉमिनेटर मध्ये जो आहे ही टर्म त्याची नवीन व्हॅल्यू काढायचा प्रयत्न करतो. सो हियर we can take this r square common. r square common घेतल्यानंतर काय राहील, it would be 1 plus tan square t, 1 plus tan square t, and this whole bracket raised to 3/2, right? So here I can write now what I can write. What is meaning of 1 plus tan square t?
Sec square t.
Yes, so this becomes r square sec square t bracket raised to 3/2. So this by 2 gets cancelled with those squares, right? So final equation that I will get here is what I will get, r cube sec cube t, r cube sec cube t. Are you getting this equation how I have written?
Yes sir.
ओके. बघा आता आपण या इक्वेशन पासून सुरुवात केली. आपल्याला पहिला तर लिमिट्स नवीन भेटले, ठीक आहे. म्हणजे ह्या लिमिट साठी सबस्टिट्यूशन करणार आहे तुम्ही, त्यानंतर dz चेंज करणार आहे. dz च्या ऐवजी आता आपल्याला काय लिहिता येईल, dz च्या ऐवजी काय लिहिता येईल, ही व्हॅल्यू, ठीक आहे ना, r sec square t dt. आणि त्यानंतर आपल्याला ह्या डिनॉमिनेटर मध्ये r square plus z square bracket raised to 3/2 याच्या ऐवजी काय लिहिता येईल, r cube sec cube t, r cube sec cube t. So those many substitution, those many changes we can do now. So for that, if I rewrite the equation, what I will get is, so here simply I will write as this is equation number 2, right? So equation 2 becomes E bar is equal to, equation 2 E bar is equal to integration. Someone help me. Limits.
Minus pi/2 to pi/2.
Correct. Minus pi/2 to pi/2. Further, rho L as it is. Rho L as it is. Then we have R here, right? We have R here, and from equation of dz, which is written here, there also we are having R. So simply what I will write, R square. So it becomes r square. Then here we have sec square. Sec square t dt. Sec square t dt. Sec square t dt divided by, of course, this a bar r would be there, divided by 4 pi epsilon naught as it is. 4 pi epsilon naught as it is. What we have here is, for this term, we have written r cube sec cube t, right? So this is r cube sec cube t. Is it clear so far?
Yes, sir.
Now, what things are going to be cancelled here?
R square sec
Yes,
square t.
this is going to be cancelled. So we can cancel those numerator denominator terms. So what would remains, that I will write here. E bar is equal to, E bar is equal to, the constant terms I will take outside of integration. Constant term means rho L will not change. Rho L is constant. Then this direction would remains there throughout the term. So a bar r I will take out. 4 pi epsilon naught, 4 pi epsilon naught will not get changed. And one more term which is not going to change, can someone tell?
R.
Correct. R will not change. The distance of that point will not change, right? So this R I can take outside. Why R? वरती न्यूमरेटर मध्ये r स्क्वेअर आहे, डिनॉमिनेटर r क्यूब आहे, बरोबर आहे. सो काय राहील शेवटी, डिनॉमिनेटर मध्ये r. Yes. Then we have integration. Integration limits would be same, minus pi by 2 to plus pi by 2. ठीक आहे. त्यानंतर इथं काय येईल, 1 अपॉन
sec t.
1 अपॉन सेक टी. आता 1 अपॉन सेक टी च्या ऐवजी जर मी डायरेक्ट कॉस टी लिहिलं तर,
Yes, sir. Correct.
yes. So instead of 1 upon sec t, what I will write here is cos t. Cos t. ठीक आहे, dt. So आता जस्ट आपलं काम राहिलं एवढं सॉल्व करायचं, राईट. सो हाऊ यू विल सॉल्व, E bar is equal to this term as it is, that is rho L divided by 4 pi epsilon naught r, A bar r here. So here what I can write, if I take the integration of cos, it would be, it will be, what is the integration of cos?
Minus sign.
Minus or plus?
Plus sign t.
Plus.
Yes. So this is going to be sin t. Sin t. Right? And this would be minus pi by 2 to plus pi by 2. Right? So now if you could solve this, means what value you will get in place of this. You have the calculator, calculate this and tell me the value of this underlined thing. Rho L upon 4 pi epsilon naught r, A bar r, and I want the value of this. Sin pi by 2 minus of minus sin pi by 2. sin pi by 2 ची व्हॅल्यू काय येते?
1.
1 minus of minus 1 म्हणजे 1 plus 1 value is 2, right? So but we have here 4, so this equation could be simplified to e bar is equal to rho l upon 4 pi epsilon naught, sorry, this is 2 pi epsilon naught. Two pi epsilon naught. This is now I have written this for the distance having r, right? So we have taken like the charge is placed, line charge is placed on z axis, and the point is separated at a distance small r, and then we have analyzed this. So this is a specified case. Here we can generalize this equation. This is in general. I will replace this as capital R, a bar r. This is the final equation. This is the final expression for electric field intensity due to infinite line charge. So what would be the unit of this? Unit of this is volts per meter. This is what called a general expression for electric field intensity. What it is called as electric field intensity due to infinite line charge. Infinite line charge. Is it clear? So take this equation on a note, write it down somewhere. Very, very important equation. Every now and then it is required. At least 1 or 2 examples will be asked on this concept, and you have to find the electric field intensity due to infinite line charge. And hence this is very, very important. This equation is very important. समजतंय काय डाऊट आहे इथपर्यंत? Shall we solve one example? बघा, म्हणजे आपल्याकडे 3 स्टेप्स होत्या. त्या 3 स्टेप्स यूज करूनच आपण या इक्वेशन पर्यंत पोहोचलोय. म्हणजे आता आपल्याला प्रत्येक वेळी एक्झाम्पल सॉल्व्ह करताना त्या 3 स्टेप्स फॉलो करायची गरज नाही. म्हणजे क्रिएट डीक्यू, देन काय म्हणतो आपण, त्याच्यावरून डिफरन्शियल इलेक्ट्रिक फील्ड काढा आणि त्याचं इंटिग्रेशन घेऊन टोटल इलेक्ट्रिक फील्ड काढा. याच्याऐवजी आपण हा फॉर्म्युला डायरेक्ट वापरायचा. वी विल गेट द आन्सर. समजतंय? Shall we proceed to solve one example?
Yes, sir.
Okay. So let us take one example. Yes. So the example, uniform line charge of 120 nanocoulomb per meter. Example. Uniform line charge of 120 nanocoulomb per meter lie along 3 axis. Full stop. assuming free space condition. Assuming free space condition. Assuming free space condition. Find E bar at. Find E bar at. Find E bar at -3, comma 2, comma -1. बघा आता इथं काय करायचं आपल्याला. Let's try to draw the picture from given scenario first. So let me try to draw this. So this is your Z axis. This is the Y axis, right? And this is the X axis, right? So as I said, Z, you can consider it's a positive side, it's negative side. Right? Then here we have Y, positive side, -Y. Similarly, X, -X. Right? So this is how we can draw the coordinates. Now from given information, uniform line charges. Uniform line charges. Let us make this change. These are charges, three charges lie along 3 axis. आणि त्याची व्हॅल्यू पण दिलेली आहे. व्हॅल्यू इज 120 नॅनोकुलॉम per meter. What it is? It's a line charge density. So from given information, what I can write? Rho L, value of rho L is value of rho L means line charge density. It is 120 nanocoulomb per meter. Right? So this is what given. And they have mentioned uniform line charges of this much line charge density lie along 3 axes. So ह्या ज्या 3 लाईन्स आहेत, ठीक आहे ना, 3 लाईन्स आहेत, त्या कुठं आहेत? ह्या त्या तीनही ऍक्सिस वरती आहेत. त्या तीनही ऍक्सिस वरती आहेत. म्हणजेच काय? त्यातली एक लाईन चार्ज ह्या एक्स ऍक्सिस वरती असेल, एक लाईन चार्ज झेड ऍक्सिस वर असेल आणि एक लाईन चार्ज ही कुठे असणार आहे? वाय ऍक्सिस वरती असणार आहे. ठीक आहे, म्हणजे तीनही ऍक्सिस वरती आपल्याला लाईन चार्ज त्यांनी दिलेला आहे आणि त्याची व्हॅल्यू पण दिलेली आहे, त्याची चार्ज डेन्सिटी पण दिलेली आहे. ठीक आहे. सो दिस मच इन्फॉर्मेशन दे हॅव गिवन अँड they have asked you to find the electric field intensity at some point, let's say here. What is that point? The point is -3, comma 2, comma -1. Right? So if I project this point, like if I take it on a z axis, it will intersect. Where it will intersect? It will intersect at
-1.
correct. It will intersect at -1. So if I extend this on y axis, where it will intersect?
2.
Correct. It will intersect at 2. And if I extend this on x axis, where it will intersect?
-3.
Correct. It will intersect on -3. Right. So here it would be -3. Right. So we got those points. Now here I will highlight those 3 points. One is here, one is here, and one is over here. Right? So those 3 points I would like to highlight. So how I can write those points now? How I can write? If the point is here, it will be your 0, 0,
Minus.
-1. Correct. Now, for this point, it will be 0,
2, 0.
0. Correct. And for this case, it will be -3,
0, 0.
0, 0. Correct. Absolutely correct. आपल्याला हे सगळे एंड पॉइंट्स मिळाले. आता वेक्टरच्या डायरेक्शन्स कशा असणार आहेत? त्या पॉइंट्स कडून आपला जो पॉइंट आहे त्याच्याकडे डायरेक्ट करणार आहे, बिकॉज वी वॉन्ट इलेक्ट्रिक फील्ड इंटेन्सिटी लेट्स से ॲट पॉइंट पी. ॲट पॉइंट पी ला इलेक्ट्रिक फील्ड इंटेन्सिटी आपल्याला काढावी लागणार आहे. मग ह्या वेक्टरची डायरेक्शन असेल दिस वेक्टर विल हॅव दिस डायरेक्शन आणि ह्या वेक्टरची ही डायरेक्शन. ठीक आहे. आता त्यांना आपण लेबल देऊयात. म्हणजेच काय की जर एक्स ऍक्सिस कडून जो आलेला वेक्टर आहे त्याला आपण म्हणूयात लेट्स से R1. एक्स ऍक्सिस कडून आलेला वेक्टर आहे त्याला मी म्हटलं R1 बार. एक्स ऍक्सिस कडून आलेला वेक्टर आहे तो R1 बार. वाय ऍक्सिस कडून आलेला वेक्टर आहे तो R2 बार. आणि झेड ऍक्सिस कडून आलेला वेक्टर आहे तो R3 बार. ठीक आहे ना? R1, R2, R3. आता तो जो फॉर्म्युला आपण आताच्या केसमध्ये डिराईव्ह केला होता तो फॉर्म्युला या तीनही केसेसला इंडिपेंडेंटली अप्लाय करायचा. तीनही केसेसला इंडिपेंडेंटली अप्लाय करायचा म्हणजे काय? मी या तीनही केसेस इथं लिहितो. Yes. First task is to find R1. I want to find the value of R1. R1 चे coordinates कसे आहेत? Starting coordinate -3, 0, 0 आणि end coordinate -3, 2, -1. तर याच्यावरून मला R1 वेक्टर काय भेटेल? R1 वेक्टर काय भेटेल? बघा, you should be able to calculate the vector immediately. 2 a bar y, 2 a bar y minus a bar z. Make me correct if I'm wrong. बरोबर आहे ना हा वेक्टर? Yes or no?
Yes, sir.
Okay, then we have R2. R2 bar, it is equal to R2 म्हणजे y ऍक्सिस कडून आलेला वेक्टर. Value of R2 is -3 a bar x
-1 a bar z.
minus a bar z. Correct. आणि R3, vector R3 is -3 a bar x -3 a bar x plus 2 a bar y. Is it correct? Is it correct?
Yes, sir.
Okay, now we have to find the unit vectors as well. So a bar R1, it is equal to 2 a bar y minus a bar z divided by, can someone tell me? Under root
2 square
2 square
plus 1 square.
1 means 5, right? So under root 5. Then here I can write a bar R2 is equal to -3 a bar x minus a bar z divided by,
Under root 10.
correct, under root 10. And here a bar r3 is equal to minus 3 a bar x plus 2 a bar y divided by under root
13.
13, correct. So we got unit vector, you got vectors, unit vectors, etc. Now you can readily use the formula which we have derived just now. Ata he has a formula I will write for those separate cases, like electric field intensity due to infinite line which is spaced, which is placed on x-axis, let us say EL1 bar. It is equal to, we have rho L upon, just now we have derived this formula, 2 pi epsilon naught R1 a bar R1. Similarly, I can write here EL2. EL2 is electric field intensity due to infinite line charge placed on y-axis. So here what I can write, rho L divided by 2 pi epsilon naught R2 a bar R2. And here EL3 is electric field intensity due to infinite line charge placed on z-axis. So this is rho L upon 2 pi epsilon naught R3 a bar R3. समजतंय का इथपर्यंत?
Yes, sir.
Okay, so let's solve this for first case. It is equal to, let us put on the values. Rho L ची value किती दिलेली आहे? 120 nano coulomb per meter. So this is 120 into 10 raised to minus 9 divided by 2 pi epsilon naught ची व्हॅल्यू तुम्ही जर 10 raised to minus 9 घेतली तर सिम्प्लिफाय करायला सोपं जाईल. 10 raised to minus 9 upon 36 pi. ठीक है, into under root 5. This is magnitude. त्यानंतर इथं असणार आहे युनिट वेक्टर. युनिट वेक्टर काय आहे? 2 a bar y. Just now we have calculated here. So 2 a bar y minus a bar z divided by under root 5. So this is equal to, you just calculate this and tell me what would be the value of this term. I will highlight it so that first of all calculate the numerator, then calculate denominator and get it divided. So this term, value of this term I want.
432.
Correct. 432. 432 is the answer. 432 into bracket 2 a bar y minus a bar z. The final answer that I can get for EL1, it is equal to
864 a bar y
864
a bar y
a bar
minus
y minus
432 a bar z.
432 a bar z. Correct, absolutely correct. What is the unit? Volts per meter. Yes. So now it's your turn to calculate this and this. You have 5 minutes. You have 5 minutes to write the answer. Solve it and tell me the answer. सॉल्व केलं काय येतात आन्सर? What answers you are getting here? EL2.
minus 648 a bar x minus 216 a bar z.
Correct. EL2 is equal to minus 600. How much it is? 648
48 a bar x
a bar x
minus
minus
216 a bar z
216 a bar z
volts per meter.
volts per meter. Okay, good.
EL3
Calculated?
yes sir,
Okay, done.
minus 498.45
Minus 400.
98.45 a bar x
Is it plus or minus?
minus
Minus 448.45.
98.45 a bar x
a bar x. Okay.
plus
Plus
332.3
333.3
a bar y.
a bar y. Correct. Volts per meter. Right. So these are what equations, these are what values we are getting, but what they have asked is electric intensity at a given point, at a point P. Right. So it is going to be a vector sum of all those electric field intensities. Keep it in mind. Just try to recall the principle of superposition. In order to find the electric field intensity at any point, all the electric field intensities are to be considered, and it is going to be a vector sum. So here I am going to write E bar total at point P, it is equal to EL1 plus EL2 bar, EL2 plus EL3, right? So you just make addition of those all components and try to find the answer of this. Total electric field E bar, it is equal to x कोएफिशिएंट, सर्वांचे x कोएफिशिएंट ऍड करायचे, सर्वांचे y कोएफिशिएंट ऍड करायचे आणि सर्वांचे z कोएफिशिएंट्स ऍड करायचे. As per my knowledge is concerned, the answer is this one. You just cross verify and check whether it is correct or wrong. 1146 a bar x plus 1196 a bar y minus 648 a bar z. Check whether you are getting this answer. Unit of this is volts per meter. Check you are getting this answer or not.
Yes, sir, got the answer.
Okay. Right. Roll number 1 is present. Roll number 2. Roll number 2. 8. Roll number 8. 12.
Yes, sir.
Yes, 12 is present. Twenty-six. Roll number 26. 32. 32. 41. Roll number 41. 43. 46. 48. 49. Okay. So roll number 2, 8, 26, 32, 41, 43, 46, 48, and 49. Okay, so we will stop here for today. Right now, I guess there is a EMFT tute at 1:45. It will be swapped, so that's why I have taken in the morning. And then roll number 30. What she tried to say? No problem. 30 I have marked present already. Okay, then we will stop. You are allowed to leave the meeting now.